Hey everyone, it's Mr. Souther coming at you with a quick lesson on Unit 8, Lesson 5. So up until this point, we've learned about how to do searches, right? We learned linear search, binary search. In the last lesson, I showed you how to do a selection sort. So in order for binary searches to work, you must have your array or list of numbers be in some sort of ascending or descending order for that matter, in order to work out. So in lesson 4, we talked about doing a selection sort. Now we're going to kind of look at a part where we look at basically doing this insertion sort portion. So let me walk you through the slides, and once you see the graphics, code.org did actually do a good job with the animation, so you can see how we're going to sort the numbers. In terms of objectives for today, again, we're all about efficiency. So the less iterations it takes, the faster the program will be able to run, and the faster we can sort and then search for something, the better the function of the program will be. Okay, so let's get straight to what we want to do, and then I'll get to the code. Insertion sort basically starts to shift around items. Again, we have to do it one at a time to find the correct position in the list. So let me go through a couple iterations of this, and it might not be like that clear on the first attempt, but I'll run it. I guess you can also rewind or go back in this video to see. So I have the same 4 set of numbers we've been dealing with in other classes or the previous lessons. We got 30, 10, 40, and 20. And basically we want to sort them in ascending order, right? So 10, 20, 30, 40 is what it's going to look like. So when I do this the first time around, we have index value of 1, and that current index value is going to look at 10, right? So we know 10 is going to be my target. So then the next thing we're going to do is we know that we want that value at 1, index value 1, to be at index 0. Well, how is that? So again, when I'm taking a look at 10, I know 10 is the smallest number of the set of 4 numbers, right? So I want that to come first. So let's go ahead and identify 30 and 10. So the 10 is the current index. The previous index is 30, and we want them to switch. So the first thing I'm going to do is I'm going to assign 30 to a temporary value that's going to go ahead and dump it into that index value 1. And at the same time, I need to bring about the next value, which is now what's going to happen is we're going to decrease that next index value from 0 to -1. Obviously, there's no -1 value, so then the default will be the first position, which is that index value 0, where 10 is going to go. Okay, so then now you'll notice a subtle difference there. The index value went to 2, and then we're going to go ahead and identify what that value is, which is 40. And then we're going to need to take a look at, well, how does that compare, because that's our current value that we're looking at, to the previous index value, which is the 1, which is 30. Right? So we can see that 30 and 40, do those need to switch positions? Well, the answer is no, right? Because 30 is smaller than 40. So then we're going to take a look. If it keeps going, it should go to 20. There it goes. Now we're going to identify 20 and see how that compares to the previous index value, which is 40. And then we're going to go ahead and swap those two. All right, so 40 goes to the end. 20 could move up, but in what we do, one thing I forgot to mention, sorry, let me back up for a second. So 20 and 40 need to switch places, essentially. 40 needs to be the last number here. So we're going to take 40, we're going to shift that down. So it's going to remain 40. In case you're wondering where the 20 went, again, we're using a temporary variable to store 20 so it doesn't get lost. And then now we're going to go ahead and identify the 30, right? And move 30 over. And then finally, we're going to be able to target 10 to see, is that greater than or equal to 20? No. And then we're going to go to 30 and see that 20 is less than 30. Therefore, we'll put 20 there. Okay. So again, kind of going back to the positions that we went through very quickly, just so it's obvious here. So we're going to start with index value 1, and we're going to go ahead and store the value of current here. So current is going to hold on to the value of 10 so it doesn't go away as I'm trying to move it. And the idea is I can kind of, instead of going one element at a time, I can select targeted elements to go ahead and insert the value there. Okay, and we're going to show this on the code, so don't worry. I can keep going, blah, blah, blah. And then what code.org did is they made kind of this algorithm just to try and type out like what's actually happening. So we're going to have to use loops again, and we're going to list from index 1, or we're going to use a loop list to go from index 1 to the end of the list. You're going to set that current value at whatever the index value is, and then the next index value will be set to a -1. We're going to keep doing a while loop where next is greater than or equal to 0, and the value next is greater than current, then we're going to go ahead and take that element at the next index value and get the value at that next value. I'm going to decrement and then go back to next plus one. Let me actually show you the code. So I'll pause here and then we can get going into it. Okay, so now I have the code up and running. I kind of want to just go through these modules because all you're doing here is just copying and pasting the code they want you to add. The main thing is we got to notice what's happening. What's already given here is they have a sort runner here for the tester class. There's a set of numbers 30, 50, 10, 40, 20. When you're using insertion sort, we're going to go ahead and run this. I'll go ahead and run this so you can see what comes out before I start messing around with the code. Okay. Actually, let's go ahead and do this for time's sake. We'll go ahead and run it, and then I'll be able to pick apart what's happening. So the first kind of set of the sorts is going to look at an insertion sort for two different numbers here, or for the first set of numbers, 30, 50, 10, 40, 20. And then we're going to compare that to the selection sort. So selection sort would have come back from lesson 4. We just did that. So I'm going to go all the way up. Okay. So I ran this thing. If we're doing insertion sort, you'll see that there is the comparison information that we put in. So the first thing it's going to do is 50 is the second index value, so index number 1. 30 is the 0th or the first element, right? So I'm going to go ahead and compare 50 and the previous value 30. And then what it did was it went to the next value, which is 10, and compared it to 50. Okay, so again, we looked at 50 versus 30. And now we jump over to, so since we're done with 50 and 30, so basically they're saying, hey, 50 is greater than 30, so let's move on. Then it looked at 10 and compared to 50, and also kept with 10 and compared to the first element, 30. And then it decided that, oh, 10 is actually less than those two elements, those values, so we're going to go ahead and put it to the top. And it kept going on and on and on. And then after insertion sort, you'll see that it is in the correct value order. When we use selection sort, that's where we actually went ahead and went kind of, remember, we compared two elements at a time as we traversed essentially through the array. So I'm going to just take note that it took 9 comparisons to basically do the sort for insertion sort. When we do the same thing for selection sort, we did that in the previous lesson, it took 10 iterations. Okay, so it works, right? But it did take a little, like 1 iteration longer. Now, at first glance, you're like, 1 iteration is not a big deal. But again, this is only 5 set of numbers. What if we did this for 5 million, right? Then it starts to add up. The inefficiencies will start to add up. So that's that. Let's go on to module 2 because there's more code there that I'll go over. And then check it out. So in module 2, we now have, again, the code's just going to carry over from one module to the next. But in this case, what I did, and I tried to put this in the comments ahead of time, is we're basically going to create that 1D array with values in sorted order. And then we did the insertion sort. If I'm not mistaken, sorted numbers, sorter. Yeah, so we're going to go ahead and do that insertion sort method here. So let's go ahead and check out what's happening in that module 2 program, okay? At the same time, we also did it in reverse order, just so you know. So let's take a look and see. So again, going back up to the top, the first thing we did was we did the insertion sort, right? And then we did the selection sort, compared the two. Now we're going to do and I put in the text so that I know this is from module 2. We're going to go ahead and compare 10 and 5 when we start. So these are already in numerical order, right? Ascending order. So 5, 10, 15, 20, 25 is what I chose. What you're going to notice is that it took 4 iterations or 4 comparisons to come up with the sort. Okay, so when we do an insertion sort, we're very particularly looking at the index value 1, comparing it to the previous method, and we're comparing it to the previous element, 5. So we're going to start with 10, which is the index number 1. We're going to compare it to the previous value, 5, and the next value, 15, and do a quick comparison with those two. It is broken down one number or one set of numbers at a time. And then we're going to go ahead and move that value 10 around as needed if we need. So then we're going to go ahead and compare 15 and 10, right? So this is all revolving around 10. So I'm looking at the two values right around that 10. And you can see that 10 is in between 15 and 5. So we're just going to keep it there. And we do the same thing for 20 and 25. And you'll notice they only took 4 comparisons, okay? If we go in reverse order, takes a little bit longer, right? Because now I'm trying to go from 25, 20, 15, 10, 5 and going through the insertion sort. And this still only takes 10 comparisons to move. So in this case, we had to move every single number, right? So the insertion sort, if you look at it this way, is still pretty efficient. And so it's really helpful. So again, let me move over to module 3, and then I'll show you, we'll dive into the code a little bit more and then wrap this up. So again, the difference you might be asking between selection sort and insertion sort is we're going to go ahead and compare. With selection sort, I would have done kind of one element at a time. So we looked at 5, compared it to 10. Looked at 5, compared to 15, right? So we've kind of gone one array or one element at a time with each other, right? So we go 5 versus 10, 5 versus 15, 5 versus 20, 5 versus 25, lock in 5. Then we move to 10, 10 versus 15, 10 versus 20, 10 versus 25, then lock in 10. Right? Versus insertion sort is merely looking at, we're skipping that first index value and we're trying to compare that second index value to the previous value and the one after it, kind of simultaneously, if you will. I mean, it takes one extra comparison, but that's there. And when you do it this way, it's actually more efficient. So if I go to sorted.java, just so we can see it, there's the insertion sort. It only needs that array to be fed in. It's running that for loop, which is really important to go ahead and we're basically going to take that index value, storing it in this temporary file. That was the current in the slideshow. Go ahead and initialize index as value I. And the reason we're doing that is, at least my understanding is, we have a for loop and there's a while loop within it where we're going to use the index value. So I wanted to make sure that the index value, we're going to start with 1, doesn't conflict with the other while where we have index value greater than 0. Okay, so I need the two to be kind of separate, not tied together. Okay, so then we're going to take so basically what we're going to do is we're going to compare that array, the previous value. We're going to set it equal to the current index value, and then we're going to do a decrement. So long as the index value is greater than 0, and that data, this previous element is a value greater than the temporary value. So in other words, so if I did 5, 10, or if I did 15, 10, and 5, the current data bracket index would be the 10. Data index -1 would have been the 15, right? So 15 is greater than 10. Then it's going to execute and try and do a swap here. And same thing with this if. And then it's going to go ahead and add 1 to the comparison, just saying, hey, as long as we're actually running this, every iteration, go ahead and count 1 more to the num compares. That's what's displaying. And it's going to go ahead and say what the current array is. So that's that. So again, the main thing to take away is when we do an insertion sort, we're taking a look at not the first index, but the second index and comparing the previous index value, and the next index value, kind of one after another. And then we're going to go ahead and move it to whatever index value is actually smaller. So by doing that, you kind of become more efficient. So that's that. Take a look at the code a little bit more, and we'll do some practice as well. So enjoy.